Good afternoon to all of you. Myself, Raj Kishore, General Manager, Engineers India Limited. First of all, I would like to thank Resonance Energy for organizing such a nice conference and inviting me as a speaker. Today, I am going to talk about the learning from incidences due to design and construction. So I am going to cover the following topics, that is pipeline across Brahmaputra River. Second is pipeline at Amba Ghat and Tilari Ghat, that is in western part of the India. And third one is clubbing of class 1, class 2 and class 3 locations in gas pipeline during hydrostatic testing. And fourth one is pipeline through sand dunes in Thar deserts of Rajasthan. And fifth one is stress analysis due to heavy construction loads. So due to paucity of time, I will just go through it. And if you see, the pipeline design and construction often demand more than technical planning. They require basically dynamic decision making across, basically against the regulatory constraints and engineering challenges. So we have to basically going to present the real world incidences as per the experience and engineering insights encountered during the design and construction of pipelines. So objective of this to transform the field challenges into engineering knowledge is strengthening our ability to design resilient, safe, cost-effective pipeline systems. So first, I am going to talk about the pipeline across Brahmaputra River. If you see, this pipeline is basically 1630 kilometers long. This crosses 5 states. It starts from Odisha, then goes to West Bengal, then Jharkhand, then Bihar, then again West Bengal, and finally it terminates in the Assam in Numaligarh. This pipeline crosses almost more than 200 rivers, because most of the rivers comes from Himalayan region. So during design stage, if you see DFR stage, this pipeline was supposed to cross from Gohapur to directly Numaligarh. If you see this area, this is Gohapur, and this is basically you see the Numaligarh. So this pipeline was supposed to cross by this way. Then this location, actually, if you see, the river is almost 8 kilometers wide during DFR stage. But when it comes to design stage, almost 4 to 5 years later, at that time when we studied this location, the crossing width becomes almost 13 kilometers, because Brahmaputra changed its river course. So if you see the route of this pipeline, this is the route of this total pipeline, and I am showing this area only. So if you see this way, this is the basically Gohapur to Numaligarh, direct crossing. This is almost 13 kilometers wide. So we have studied, and if you see the islands, whatever studied during the DFR stage, these islands were big at that time. But after 4 years, they become half of that, because these are the sandy islands. So whatever the feasibility at that time was done, that is not possible after 5 years due to river course actions. So we have gone through the Google imageries and studies year 2005, year 2012, 16 and 19. We found that these islands are changing day by day. Means every time when basically flood is coming, river islands are changing, location are changing. Then we have done a survey along the pipeline through a boat with a team of NRL, EIL and survey agency. Full day we have gone to the inside the river through motor boat and travel from Majuli to Gohapur, full day. Then we have find the location at Majuli, where river location is only 6 kilometers wide. And in Google imagery, we found that this location and these river banks are stable. If you see the Google imagery of 1984, this is the 1984 Google imagery. These banks are stable and river course is also not changing much. So accordingly, we have decided the location, the pipeline crossing at this location. Though this has changed the pipeline length almost 70 to 90 kilometers, means additional length. But when we obtained the budgetary estimate for the Gohapur to Numaligarh direct crossing location, because HDD was not feasible, we have searched out to micro-tunneling. So micro-tunneling for such a length in such a micro-tunnel is not possible. So people have suggested, and we have engineered that big tunnel to be done, more than 3.5 meters. And cost was almost 1,500 crores for that tunnel only. By increasing the length of 70 to 80 kilometers, almost 1 kilometer cost, because this pipeline is 26 inches. So almost 5 crore per kilometer, almost 450 crore. Only means we have saved almost 1,000 crore by crossing this way of this pipeline. So this is the basically main islands, and this is the location where we have crossed the pipeline. So we have done the 4-kilometer section by HDD with intersect method, and others by open cut with concrete coating, and some portion wherever branches are there, that is also HDD by that. This is the pipeline across Amba Ghat and Tilari Ghat in Dabhol Bangalore pipeline. If you see these ghats, Mr. Soni Saab was there at that time in EIL. We have visited those locations. Even people are saying pipeline cannot be laid in these stretches because slope is so high. If you see, that is 35 degree in Amba Ghat. So accordingly, we have visited the location and we have planned how to lay the pipeline and what are the design changes are required during design stage in the pipeline. First constraint was how to do the hydro test of the pipeline, because elevation is so high. If you see, the elevation is almost 600 to 700 meters. So accordingly, we have chosen the pipe thickness of 19 millimeter, because P max and P minimum difference should be more than 600 meters. Accordingly, we have changed and we have laid the pipeline and hydro tested the pipeline. Similarly, we have done the Tilari Ghat, same. We have selected the higher thickness pipe and accordingly we have carried out the testing of the pipeline. For soil stabilization, if you see the previous slide, we have basically installed the trench plugs, or we can slope breakers, because of actual dimension is actual as per that is 10 meters, but because of slope breaker will be very less distance, and we have installed those slope breakers, and we have also installed soil stabilization methods. If you see these photographs, whatever we have done, erosion control blanket also, we have done hydro seeding also, because if you see, at that time, pipeline laying for different method was almost 30 to 35 crores. But we have laid this pipeline in point spread only in 5 crores. Means we have saved the pipeline cost of almost 25 crores for those two ghats, almost 60 crores total. This is the basically slope, if you see actual. Now clubbing of hydro test sections, if you see class 1, class 2. Normally in gas pipeline, we can club class 1 with class 2, and class 2 with class 3, and class 3 with class 4. But class 3 cannot be combined with class 1. But you have to calculate, and based on the real case basis, based on the ground profile, we can club that, because highest pressure at that elevation will be lowest, and lowest elevation will be the highest pressure. Means you have to put the highest thickness pipe, means class 3 pipe, location should be in lower portion 1. Then it will basically feel the minimum, at least minimum test pressure of the section. Then you can club these class 3 with class 1 or class 2. If you pipeline through sand dunes, when we are designing the pipeline, that is Mundra Bhatinda pipeline, that pipeline is crosses through sand dunes of Thar deserts. Almost 275 kilometer portion of the pipeline was passing through the sand dunes. Then during design itself, we have rerouted the pipe, because as much as the pipeline should not go to the sand dunes, and basically then accordingly we have done the rerouting of the pipeline, and we have seen that how basically transportation to be done. Suppose pipe, there is no roads. So how transportation to be done? What type of equipment to be used for construction of the pipeline? And how water to be transported or how water to be sourced for hydro testing? Accordingly, we have find out what are the constraints and what are their solutions. Accordingly, we have done this pipeline. If you see stress due to basically heavy construction, recently we have basically laying the pipeline in the Haldia region, West Bengal. We have laid the pipeline and PWR authority came and they told that we are immediately going to construct the road. Pipeline was still unbackfilled. They have told you just backfill it. We are going to put our rollers and basically big, basically vibration come roller motors and we will basically construct the roads. Accordingly, we have said that because directly you are putting the vibrating roller, then it will damage the pipeline. So we have designed a solution. We have given a steel plate. A steel plate, you put a roller on a steel plate and vibrate it and put a load, then it will basically distribute the load. And it will make the pipeline safe. Accordingly, they have done it and we have completed this section of the pipeline. So key takeaways of the pipeline, basically pipeline design must adapt to the real field conditions. Challenging terrains require specialized solutions. Strengthen route finalization practices. Hydrotest section planning is very critical in pipeline design itself. Stress analysis and integrity checks must be strengthened. Therefore, I can say that ultimately these learnings emphasize that pipeline integrity is not ensured by design alone. It is the continuous alignment of design intent with field execution, risk mitigation, and informed decision making at every stage. Thank you.